Okay, so here we are. Today we're going to talk about transformations. So for transformations, again, we're working in that unit 3, which is intro to graphing. So if we look at that word transformations too, we can always think of it as, right, the beginning of that word is trans, and I always like to think of transportation, right? And transportation, we talk about moving cars, right? Or moving vehicles, right? How do we get from one place to another? So when we talk in the graphing world about transformations, we are going to talk about moving graphs. Right? So that's what we're going to talk about. It's the last new skill that we're going to learn for this unit. So f of x is another way of writing y. And we call this, what do we call this? I'm going to ask you a question right now, and you're going to fill that out for me. So f of x is another way of writing y, and we call this, hopefully you are able to write functions. We call this functions. The first type of transformation then we're going to talk about is going to be vertical transformations. So when we talk vertical, I like to just draw this, is we are going to talk up or down. So vertical transformations are moving up or down. So it says use the table and graph to answer the problem below. So when we plot these initial points, we are plotting what we call a parent function. And the parent function for this is f of x equals to x. And that gives us a linear, right? A linear graph that we can see there. Okay, that's our main graph. So when we start, we're going to start with the example on the left here, y equals f of x plus 2, talking about vertical transformations. So this plus 2 here is going to shift my graph up 2 units. So let's complete the table though first. So then we have, if we have f of x plus 2, we are looking at 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. And 3 plus 2 is 5. So those are our new points. So let's go ahead and graph those points. 0, 2. 1, 3. 2, 4. And 3, 5. So you are able to graph our new line. And I'm going to zoom out here, right, so that you can see the movement from our original graph to our new graph that had a transformation of up 2. So the next example here, we have f of x minus 3. So this is going to shift my graph what? And to help you make that inference, if you look at the first example, we had plus 2, and that moved my graph up 2. Now I have minus 3. So how is that going to shift my graph? Hopefully you were able to write that it shifted your graph down 3 units. Then we will fill out our table. So we are using the original f of x values and minusing 3. So I have -3, 1 minus 3 is 2, 2 minus 3 is -1, and 3 minus 3 is 0. And now we're able to plot those points. So my points are 0, -3, 1, -2, 2, -1, 3, 0. And I can draw a line here to create my new function, my new graph. So you can also now compare. So you can see how your original graph way up in the top, right, compares to your transformation graph. So we moved this graph down 3. Right, so that is our vertical transformations. We know it's vertical transformation because it's after the f of x. Let's go on to the second page here, and the second page is on horizontal transformations. So horizontal transformations is going to go this direction here, and we are going to be looking for left or right movement. So use the table and graph to answer the problems below. So our first initial graph is for us, and it's A. What type of function is this? Let's see here. So I'm going to ask you that question here. What type of function do we have? Drawn there. All right, hopefully you were able to say linear. It is just a straight line. Okay, now we're going to look at our examples. Pretty similar to what we did before. So now if I have x plus 2, do you see how the difference here is that this is in parentheses? So when this is in parentheses, that's how we know left or right. If it is a plus, that means it's going to go to the left 2. So all of my initial points here, I'm going to make a couple points on my initial graph. And I'm going to move each of those initial points to the left 2. So let's just make these little purple dots here for my initial points. And then let's change to green, and we're going to move each point over to the left 2. So I am moving each of these points right to the left 2, and that is my new linear graph. So let's see if I can make, let's see. Oh, let's just undo that. Let's see if I can make this so you can see it a little better. So if I zoom in here, these purple dots were my initial points, and I moved my graph over 2 units to the left to get my new line, and I moved it over because I had plus in the parentheses there. The next example here then is going to be y equals f of x minus 3. So here we have minus 3, and that's going to move my graph to the right 3. So I can start with my initial points from my initial graph again, making those in purple. And then let's move over to blue, because I am going to move each of these points over 3 units. So if I start here, I can go 1, 2, 3, there's 3, there's 3. So each point is going over 3 units. to the right to make my new line. Okay, so it's really important to look what is in the parentheses because it is a little tricky. It's like the opposite of what you really want to think, right? The left versus the right. So this orange box here is a great box to fill in. So if we have, as a cheat, y equals f of x plus, right? And we can use the variable k just as a filler here. So if it's plus k, that means that my transformation is up. And if it is minus k, that means my transformation is going to be down. Then we tend to use the variable h here for horizontal. So if it is minus h, I am going to go to the right. And if it is plus h, I am going to go to the left. And notice the parentheses here, right? That's key. In the parentheses, right, is horizontal. After the parentheses is vertical. So let's do these practice together. So you have your first example is f of x, or y equals f of x plus 2. So what I think is, do I have anything in the parentheses? No, so that means I have no horizontal movement. But I do have plus 2 after, which means I am going to go vertically. I'm going to go up 2. U2. Next example. I am looking what's in the parentheses is horizontal. I have minus 5. So you can always go back to this chart and reference, right? Reference, you have minus 5 here. So that means I'm going to go to the right 5 units. And I have nothing after, so that means I have no or none, no vertical movement. So let's continue working through these. So if I have in parentheses x plus 1, what is your horizontal movement? After the parentheses, we have plus 7. What is your vertical movement? So let's do another example together. In parentheses, I have x minus 1. So that means I go to the right one. And minus 9 after the parentheses, which means I'm going to go down 9. So your turn again here. If you have in parentheses x plus 5, what is your horizontal movement? And minus 2, what is the vertical movement? Next example, f of x minus 10. What is your horizontal movement? What is your vertical movement? Next one, y equals f of x plus 8 in the parentheses is plus 8. So that means I'm going to go to the left 8. And I have no vertical movement. And the last example, f of x minus 2. What is your horizontal movement? And plus 3, What is your vertical movement? All right, the last part of this is this great little reference that you'll have here. And this is saying, describe the transformations. So to graph them. So we are always going to start with our parent function. Okay, I'm going to write that here again. So our parent functions are going to be y equals to x, y equals to x squared, y equals to the absolute value of x, and y equals the square root of, oh boy, the square root of, I meant to click the back button here, the square root of x. So those are the 4 parent functions we are going to work with this whole year. And they always start at the origin. And using our transformations, we move them. So this first quadratic function is y equals x squared. And if we look at the first example here, we have x squared plus 5. So I don't have anything in parentheses, so no left or right movement. And plus 5 is meaning I'm going to shift my graph up 5. So we're just going to, for ease, make 3 points. I'm going to move each of those 3 points up 5 units. And that's my new function. So here, let's go back to purple. Here I would write up 5. The next example, I have x minus 2 in parentheses squared. So this means I am going to go to the right 2. So I move each of those points to the right 2. Okay, and you have your new function. We'll do one more example here. First, I like to write what is my movement. So I have x plus 1 means I go left 1. And then I have minus 3 at the end, which means down 3. So each of those points, I'm going to move left 1, down 3. So left 1, down 3, new point. Left 1, down 3, new point. Left 1, down 3, new point. And that's how I'm able to graph this. Now you don't have to put these lines that I had drawn in there, but I do follow my pencil or my stylus in our case now, to plot those points. It does help me. So let's look at the absolute value graph. Same concept when you're going to be doing the transformation. So I'm looking, okay, there's nothing in the parentheses, which is my absolute value signs. So that does not move. And the minus 7 at the end means down 7. So we're going to make 3 points here on my graph. And I'm going to move each of those points down 7. And you can move your graph. Next example, I have x plus 10, which counts as my parentheses, and this means I'm going to go to the left 10. So I can move my graph, each of those points to the left 10. Takes me slightly off my graph, but we just improvise and make up for that to graph my points. Next one, I have x plus 4. And that's in the absolute value sign, so that's like going left 4, minus 8, down 8. We can move our graph left 4, down 8. Regraph my points. And you can graph your points there. Same concept for square root. So let's go through this. If you have y equals the square root of x plus 6, what's your transformation? If you have y equals the square root of x plus 9, what's your transformation? If you have y equals the square root of x minus 1 plus 4, what's your transformation? And y equals the square root of x plus 2 minus 1, what's your transformation? All right, and that's all the practice we'll do on our transformations for now.